Okay, hi everyone. Welcome to today's second session in room 2. In the first talk, Marco Martin, a long-term contributor to Plasma and maintainer of the Kirigami framework, will tell us what's planned for Plasma in the coming years. Marco, go ahead.
Okay, hello everybody. I am Marco Martin, and I've been a contributor of KDE since pretty much a decade. I've been almost always working mostly on Plasma, so that's exactly what I will talk about today. Nowadays I'm working for Blue Systems, and I am still dedicating a lot of my time, both free and work on improving the Plasma experience. So this talk, even if it's about Plasma, will not really be that much about pretty pictures, but I'll go a bit more in depth on the internals, how Plasma used to work, how Plasma works now, and how can we make it work in the future as we are starting to do some work and still gathering idea for what we can and want to do for KF6 and Plasma 6. So how Plasma began? Plasma began in the early days of KD3 to the KD4 transition, in those very interesting times. So the first public release was with KD 4.0. That's how it used to look. It changed a lot, luckily also, since then on the surface, but many of the internal concepts are still pretty similar and very valid today. So this first part would be kind of a repetition with the training by Kevin on Friday, but we'll refresh it a bit and then go on what we can do for the future. So in the early KD4 times, Plasma was all built around a framework from Qt, which was called QGraphics View. It was an early attempt of going over the limitations of the QWidgets API. It wasn't completely successful because it was still very much software rendering based and QPainter based, but for sure it did teach many lessons. We in Plasma 5 we ported it almost completely out of QGraphics View. There are still some external applications that still do some use of it, like the Dolphin icon view. So how it used to work? There was a central class called the Corona that I guarantee back in those times, Corona was a completely innocent name, even though nowadays it probably really needs a new name for obvious reasons. It was the reason was with the corona of the sun, which is where the plasma lives. That was a subclass of a Q-graphic scene. So the corona was what contained every single graphical element that you've seen in the Plasma desktop and Plasma panels. As the first level, this corona contained objects called the containments that could have as many as we wanted. They could be desktop containments, so your desktop wallpaper with icons on desktop, widgets and whatnot. One for each screen and one for each activity. And it also contained the several panels. All of them were containments. A containment was a subclass, and still is a subclass of applet, which at those time it was a subclass of Q-graphics widgets. So applet was both the center of the logic of the plasmoid and of the graphical representation. A containment, as the name suggests, it could instantiate inside of it many applets. So it could contain the desktop could contain many widgets, and the panel could contain many components as well. Your start menu, the task manager, the system tray, and whatnot. A plasmoid usually was a C++ plugin which extended subclasses either applet or containment. Later, we built several bindings of different languages. We had JavaScript that way before QML, where it was still not a thing. So it was JavaScript, but very imperative based. And we had Python and Ruby. And just in the last years of KD4, we introduced the QML binding that later in Plasma 5 it grown up and it eaten up everything else, because we were pretty fed up to be sincere with Q-graphic scene. QML was also Q-graphic scene based in Qt 4. In Qt 5, it introduced its new rendering engine, the QML scene graph, and we wanted to go there. Also, because with this completely software-based rendering, there were significant performance reasons. Limitations like resizing a very big applet. Sometimes it went down to 4 or 5 frames per second, which was really not acceptable. So we very enthusiastically jumped on the QML bandwagon. As a nice side effect, the triad of the main classes in Plasma became migrated from being also graphics objects to being pure Q objects, so purely logic without a particular representation attached, which is nice. As a downside, we lost pretty much all the bindings that were not QML, but we still had all the complete language binding infrastructure that we had, even if it can have one and only one, and also those bindings were C++ plugins. So in Plasma 5 we have exactly one plugin for bindings. That is the QML one, which is mandatory to use, so it doesn't really make much sense that it's a plugin. So this thing and this component is something that we probably can do without, and we can simplify. So are we happy in Plasma Framework as is now? We all know that it's way too big. It has way too many dependencies, and it offers some functionalities that are still needed, some functionalities that are pretty okay, some functionality that are not really needed anymore. The kind of different paradigm that developed over time by development QML-based UI made some of that framework redundant. So the part of layout loading with Corona containment and applet is fine. There are some important things to change there, but it's more or less good to go, I think. Well, the big thing is containment, how it manages screen ownership. It does have problem with multi-screen. This will need a bit more thinking about. Some pieces can be, I think in KF6, they really should become their own framework. One example is all the SVG infrastructure. So to do basically exactly like we did back in the day with the K package, which was used to be a part of Plasma Framework. SVG is based on top of Qt SVG, so it is still kind of limited to tiny SVG, but it's for what it has to do, it's fine. A library that loads basic shapes is something that it's always okay. But on top of Qt SVG, it adds pretty nice features. One of it is this caching. So by profiling things, we discovered that the biggest part of startup time while loading SVG is the actual instantiation and parsing of the SVG file clearly. So it does it does on-disk caching of the rendered pixmaps, which can improve startup time of almost an order of magnitude in the instantiation time of that particular thing. Also another thing that it's pretty nice in the Plasma SVG support is a basic style sheet support. So we can recolor some elements in the SVG according to the system colors. So it's very convenient. For instance, if you have a monochrome icon theme, like most of the actions in the Breeze icon theme are, you can recolor them for different color scheme without having to have a duplicate theme just for different color schemes, at least one for light schemes and one for dark schemes. You can just recolor the same stuff. And also you can do pieces of the UI, in SVG with those pieces that follow button colors and whatnot. We also have frame SVG, which is also pretty useful. Is the classical 9 patches image used to do style decorated round rectangles that you can scale without the corners being horribly deformed. On the QML bindings, it has also some basic support for hardware acceleration, so resizing them is very fast. But we still have a complete QPainter API, so it could be well used both in QWidgets based applications and QML applications, if we get it on a low tier enough. The only concern for the tier is the use of kpixmap cache that rises it a bit, but that shouldn't be bad. Another big part in Plasma Framework is data engines. Data engines is one of the things that were a really good idea at the time. They are a mechanism for having plugin-based logic based upon data extraction and write operation with a job API. They were thought mostly for the early imperative JavaScript bindings. So also to give them to give those JavaScript bindings a kind of web feeling based API. At some point, we also had support for remote data engines, so you could have a plasmoid running on a machine, fetching data from a different machine. It was a cool idea, but never really executed to the end. An idea that, in my opinion, in other places is still worth to explore. Also with the help of KDE Connect, I guess, but not with this API. Also that API was really subject of made it too easy to do spaghetti code implementations. So most of the data engines implementation are really not pretty to look at. So it's something that we will probably retire. I already tried and did a standalone data engine library which could be used in Plasma 6 just as a porting aid, could live in workspace with the name Plasma 5 support, and for a QML plasmoid is much easier and much more elegant to instead binding a Q object with properties, signals, slots, and whatnot. Just to pay attention of not doing big sync operations in the slots, as the data engines were very explicit of in them being very async. But in general, it's something that it did teach us many things, but we probably not need that anymore. A part which is mostly okay until the step of the binding is the layout loading. So how does it work at the moment? The whole layout for the desktop is serialized in a configuration file, the applets RC configuration file. The Corona reads that, and from the top config group called containments, it reads all the subgroups. Each of the subgroups that is in the name of, in the structure of a number. So you had like containments like one. Each group with this structure will represent a different containment. So Corona will instantiate a containment instance for each one of them. Doesn't matter if they are desktops or if they are panels. Then each one of the containments restore its own config, and then looks in its applets config group. So under it will be an applets config group, and then numbers again. So for each one of those subgroups, it will instantiate a new applet, which will have the containment as its parent in the QObject sense. And then the applet will restore its configuration, and this is the part to slightly modify, in my opinion. At this moment, it loads the QML script engine plugin, which then loads the QML and creates an object of a class called the applet interface, which is a QQuick item and is the parent of the actual representation that it's contained in the actual Plasmod QML. Applet interface is pretty much a wrapper of most of the applet and containment API. So it's kind of redundant, but is the thing that gets registered as a context property in QML, in the QML root context of that that applet as that plasmoid object, which you can see it used all over the place in most plasmoids implementations. You can access plasmoid.formFactor to see if you are in a panel or a desktop. You can access plasmoid.config to read and write the configuration and so on. Another part which I think it's pretty good, and I will just improve on that, is the concept of the shell packages. Those are also a collection of QML files distributed in a K package structure. They are used to customize a bit the behavior of the main windows. So mostly the panel window, the desktop window, and the configuration dialogues, and things like the widget explorer, the activity switcher, and whatnot. They were born in very late in the KD4 life cycle for Plasma Active, where we needed to have a Plasma shell much more mobile optimized, and the main desktop shell had a lot of QWidget based UI for those kind of things. So we added the possibility of redefine all of that in QML, and nowadays is used in the Plasma desktop, has as its own Plasma mobile as its own, and also Plasma big screen, which both are based on a base package called Plasma Nano, which its biggest target is mostly just to be minimal. I will later talk a bit about just a detail how I would make them slightly better. Then here, those are the script engines. The other part that I would like to eliminate. So right now we have the applet script class in Plasma framework that then gets re-implemented by plugins. By C++ plugin, and the only plugin that we have is the QML script engine that then re-implements its own almost complete applet API wrapper. We should probably eliminate them, even if I would like to eventually get back the Python bindings, but I don't think with this API it should probably just have the possibility of shipping Python files in the packages, I guess, and then if found, execute it, and the Python file can do a QML register type, for instance, or whatever needs to be discussed. I did a very small prototype for now, but it's already pretty useful to clear our ideas. At the moment is the Plasma framework fork, which lives in my personal area on Invent. Everything that does at the moment is just loading a single view with a single containment with a single applet in. But it does have most of the required things in place. Just not all the polish, just not all the things to be able to manage multi-screen and whatnot that will needed to be taught. But with this, with that prototype and with that refactor that I'm proposing, should be possible also to lower lower the tier also of the framework significantly. I still didn't fully get rid of KXML GUI use, but I think that should also be possible. Then whether it's the result will live in frameworks or in workspace, it should be much more easy to maintain anyways. So to recap, we will have one from the current code of Plasma framework, having one framework which is the SVG stuff. Plasma framework will become basically Corona, containment, the Holy Trinity, and applet, and not much more. That and the basic loading of QML stuff also living there, and and data engines die, all the script engine stuff die. Other things like the context menu plugins, those can also probably live elsewhere, just in the final Plasma Shell implementation, probably. So the life cycle would not change significantly. The part that Corona parses applet RC and then creates the containments and then creates the applets and then containment create the applets from the config file, that would not change. The way on how containments are assigned to screens, that needs a bit more discussion, so I'm not sure yet. What will change is that the view, when it gets a containment, it will ensure that the QML part of the containment is instantiated, and then it will display it as the main thing of the view. The containment will then instantiate the QML part of any applet, not directly and not from the C++ part, but from the QML part. So on each applet pointer arriving, even just created or just created because it was restored for the configuration, it creates an instance of applet container which points to an applet, and then applet container would create the QML part. There will not be any more applet interface, but we'll still have Plasmoid in some form, but should be better that Plasmoid is just a pointer to applet directly. So on the applet side, so on the Plasmoid developer side, the structure the same, all the QML files in a K package. A thing that I would like is to force the root objects of the QML scene to be a particular class. Like usually in Qt Quick Controls and Kirigami applications, you have to have an application window. And I would like to have Plasmoids need to be an instance of Plasmoid representation, which in my prototype at the moment is a Q object that just provides two properties, compact representation and full representation, which are QML components that gets created only on demand. The Plasmoid object that becomes the applet, I would probably prefer it to be an attached property instead of a context property, which are kind of evil. This is example code, already kind of functional. So you have as root applet representation, and then you can specify a compact representation as it's today. These compact and full representations, they already exist, and as is today compact representation, 99.9% of the times you don't need that. It will just be by default that icon that is defined in the shell package. Or you could set it explicitly as null to say that you don't want it. Your Plasmoid, it's always expanded like the taskbar that you don't want to do that in a pop-up. The full representation at the moment in Plasma 5 is optional. In Plasma 6 would be in Plasma 6 would be mandatory, as the root element is not an arbitrary item anymore, and then from anywhere you could access Plasmoid in this way. Plasma core.plasmoid in any place of the QML code from any file that you call it, it will always return the same applet pointer. As I said, I would like to have shell packages slightly more powerful. I did not do experiments on that yet, but at the moment, the way they personalize like the panel window or the configuration dialog or the desktop, they define the root element of those windows. What I would like to change is them to be able to define the window itself. So the shell package would contain a panel.qml like now, but instead of having an item as a root, would have the panel view itself. So on different shells, you could have much more customized types of views that you may need in more embedded situations. Maybe you want panels to not even be a view, but be in the same view of the desktop or stuff like that. It as a wild idea, this kind of stuff, so pluggable view types could also help if at some point we decide to integrate more with LatteDoc. So LatteDoc is its own shell because it needs its own panel view with very custom features. So they could do that, and we could even load everything in the same Plasma process and having their own custom view just loaded as our panel. But still just a wild idea. If anything of everything of that will be actually done, for now is just a very early prototype and also mostly my ramblings. So the paramount objective, of course, is to have the least possible disruption and regressions for the user. But we need to talk more about it, and we will have a very long BOF on Wednesday on all things Plasma. So if you would like to discuss about that, just come there or find us in the usual channels. And thank you very much. I don't know if there is any time for questions or not, but please do.
Yeah, thanks, Marco. There's 2 minutes left, so maybe one quick question.
Okay.
By Nate, what do you envision for our long-term theming story? So he's eager about SVG-based theming.
Okay, from our long-term team, I do think the teams exactly as now need to be supported pretty much from the time for the time being, because we have a lot of third-party teams from the store, so that should stay supported. Whether is the main thing, probably in the early Plasma 6 days, it will be. What I would ask Santa about a theming engine would be something a bit more probably CSS based, which can be used by Plasma Shell, can be used by applications, both QWidgets and QML applications. Maybe also still making use, optional use of Plasma SVG SVGs as one of the many possibilities that CSS API would give. But in the end, something more unified. Even if in the end the user could still choose, I want my panels to look completely different.
Okay. Yeah.
But yeah,
Thank you,
that
Marco.
would be a lot of work and
Yeah.
still needs to be well thought about.
Okay. I guess all other questions can be talked about in the BOF meeting.
Okay.
as I mentioned.
Thank you very much, everyone.
Yeah. Thanks, Marco.
Thanks.
So next up in this room is Qt Quick 3D, and in room 1 we have Rayland Robustness. Where's Christian? Okay, Edison is going to get him. Okay, Christian arrived in the correct room.
Yeah, I hope so. Yeah.
Okay, yeah. Hi, Christian. Christian Stømme from the Qt company will show us what we can do with Qt Quick 3D in Qt 6.2. Okay, Christian, go ahead.
Oh, thanks you. Just let me get my stuff going here. Yeah, so as already mentioned, my name is Christian Stømme. I work from the Oslo office for the Qt company, where I've been for the last 12 years. Last 4 years, I've been working on the 3D offerings of Qt. But yeah, that's enough about me. Let's just dive in. So these are the topics I want to go through today. I'll start by looking at the 3D offerings in Qt and try to answer some questions around that. Before I take a look at what Qt Quick 3D is and what it provides. This is not going to be a deep dive into 3D. I'll try to keep it very simple, using a very simple example and building on that, just showing off how to get easily started with Qt Quick 3D and basically showing how easy it is to use. Yeah, I'll also take a look at mixing 2D and 3D content with Qt Quick 3D and Qt Quick. That's one of Qt Quick 3D's strong points. So I'll take a look at 2 ways of doing that. I think that will be interesting. After that, I'll take a look at the new features coming up in Qt Quick 3D 4.6.2 and say something about what we think will come post 6.2. Yeah, so these are the offerings of 3D offerings in Qt today. We have Qt 3D, we have 3D Studio, and we have Qt Quick 3. Of course, all of these provide 3D support in some way, but in a different way. First off, we have Qt Qt 3D, which is a high-level abstraction with low-level APIs. What I mean by that is it has a considerable barrier to entry. It has new concepts like the entity component system and a fully configurable frame graph. It's extremely flexible with what it can do, but I also think it's something that targets more advanced users that has requirements that are outside the two other offerings we have, 3D Studio and Qt Quick 3D. There's also a fair amount of abstraction on top of Qt 3D, which I've also mentioned here. That's mostly for the a bit historical for how we ended up with Qt Quick 3D. We actually tried to put Qt 3D under 3D Studio, but at the time we had run into severe problems scaling down to the entry-level embedded hardware we saw our users using. So that got us into a bit of problems, and we had to backtrack a little bit. And we then came up with Qt Quick 3D as a replacement together with the 3D Studio as a replacement. No, sorry. See, there's many 3D solutions here. 3D Studio, Qt Quick 3D will, together with Design Studio, will be a replacement for 3D Studio in the future. 3D Studio is a very designer-centric solution. It has a very tied engine to OpenGL. It also has concepts that feel fairly foreign to Qt, or that Qt already had better solutions for, like states and components. It also had declarative languages to describe its own scene format, materials, effects, and we felt that didn't really fit with the unification story we tried to do for 2D and 3D. And in the same way Qt 3D works, it's very self-driven, so we had extra steps needed to integrate and sync it with Qt Quick. I know there's been improvements to Qt 3D lately to improve on this. So, but this is more a historical context. Yeah, and we also wanted something even more high level and easy to use, and something that just fitted into the Qt Quick story already and integrated well there. So the result of all that is Qt Quick 3D. It has very high level concepts like camera, light, model, and those can easily be inserted in existing Qt Quick applications to add support for 3D. Qt Quick 3D is a very passive module in the sense that it only does what it's instructed to do, which is normally it gets its drive from Qt Quick. So it's more of an extension of Qt Quick than a separate thing. Yeah, I'll then go into which one I should choose. Well, as I already said, Qt Quick 3D together with Design Studio will replace the 3D Studio from old eventually. So that leaves only Qt Quick 3D and Qt 3D. And I think in most most cases, the right choice would be to pick Qt Quick 3D. It covers most 3D cases, and it integrates really well with Qt Quick. And I think the 3D needs of more advanced users will be identified by those that actually have that requirement, and they'll see if Qt 3D is the right choice for them compared to Qt Quick 3D. So,
Christian, short comment. We still see the start slide, so you need to advance the slides, and I don't know. You need to press the arrows.
Okay, so then I'm feeling. Oh, it's not. Okay, there it's changing. Okay, it wasn't changing. Sorry about that. I didn't actually notice that. Yeah, so I think this is where I'm at. Yeah. So the primary goals for us when we wanted to create Quick 3D was that it should be simple and easy to use. It should have high-level concepts like camera, light, model, and you should just be able to put that into your quick scene and get 3D content. We also wanted that there was no prior knowledge needed from the user about 3D. Of course, we had to back that with the excellent documentation, which I think we have been very good at adding. We also wanted it to be lightweight, similar to how Qt Quick initially was made. It's very embedded centric. So we always keep an eye on that we have really good performance on embedded, and I think that's something that benefits the desktop in the end as well. Another thing that was at least I feel very strongly about, is that we needed code and a renderer that was easy to understand and reason about, and be able to easily see the flow data and code. And yes, and that's also something I think we've been able to maintain even while been adding new stuff. Another key thing was that we needed it to integrate with Quick. Like mixing 2D and 3D content should be easy and inexpensive. So we didn't want to always go through off-screen rendering. We didn't want the renderer to be completely detached. So we needed the renderer to be able to talk to each other as well. That's what I mean by the unified rendering. One benefit of doing that and getting that is also that we can get really good looking text, but not just text. Like any Qt Quick item that's rendered directly into the scene with 3D transforms will look fairly good. The last important point for us was the tooling. We needed excellent tooling. We needed to have at least something as good as the 3D Studio for designers. It needed to be good for both designers and developers, not just one of them. So that's been in the back of our mind, and that's something that's important for us. And it's something that's much more important when you're doing 3D. There's much more involved with lighting and positioning and stuff like that. So artists are usually used to working in very visual tools. So if we look at the architectural overview of Qt Quick 3D, you can see it sits on top of the RHI together with Qt Quick, and it has its own scene graph with special items. And we have a tight coupling between the two renderers. The we don't do 2D rendering in the 3D engine or 3D rendering in the Qt Quick engine. We didn't want to destroy that by adding more complexity to either of them, but instead we made that it's so that they have really good communication and can do inline rendering, jump from one to the other. Another point I think is worth taking up is asset and asset conditioning. This is also something, again, that's more important or more visible when you're doing 3D. Often the content you create comes from content tools like Blender, Maya, Substance Painter, those kinds of tools. And they will export into some format like GLTF or FBX or their own formats, and we need to condition those assets into something that's efficient for our real-time renderer. So, because when those are exported, they are exported with fidelity in mind and not necessarily efficiency. So that's where the conditioning comes in. We have this tool called Balsam, interestingly enough, which is our main conditioning tool that converts formats to QML components, and it also then generates the textures and materials and everything that's needed to then put that into your application. It also has other things, like it can do texture compression, and yeah, that's what I can think of at the moment. In addition, we have the Shader Gen tool. That's an experimental tool. Again, it hasn't changed. Sorry about that. It removes. So we have the Shader Gen tool, which is, as I said, an experimental tool. It generates materials at build time by inspecting the scene and then trying to figure out what materials that will be needed in the application, so that we don't need to do that at runtime, and then therefore saving a lot of time. That's a fairly complex operation, so that's why it's still experimental. We haven't seen that much use for it yet, but that's something we're going to invest more. I also want to mention that it doesn't actually generate driver-specific shader binaries, but it generates SPARE-V bytecode that can be consumed by the Qt RHI later. So it generates materials, in essence. The next item here is the runtime loader, which is a new item for Qt 6.2. That is what it says. It can load the same assets at runtime. It at the moment supports GLTF2, and what it does is a bit opposite of the Balsam tool. The scene is not generated at build time, but it does it at runtime. So it creates all the objects at runtime, and you can reload with different type formats, now different models, and you can use the runtime loader, which is a special node to move and interact with the model, or even scenes. It's fairly new, so the API is not that extensive yet. So let's look at a minimal scene and how that looks in Qt Quick 3D. This should be fairly familiar, at least the beginning here. We have a window, and we have a view, which view 3D, which is a view into our 3D scene. We have a camera and a light and a model, and that's it. I've set the source here to be a cube. That's a built-in primitive. And of course, I've given it a material with the color green. And yeah, that's how easy it is to get started. It doesn't take much to get something on the screen. And it doesn't take that much to get something more impressive like this. I've stole this model from the GLTF2 sample library. I'm not that worst in the 3D tools that I can create something like that myself yet. But again, this is the same example. I've only changed the model to be the runtime loader here on line 30. And I've given it the source, which is the GLTF2 binary format file. And for some extra effect, I've added a light probe, which is a HDR texture, which it will use to light the model, giving a more realistic lighting condition here. And just to show that same texture, you can see maybe see the reflection of the texture in the helmet, in the shiny parts. I also set that the background mode to use the skybox mode, which means it's going to use that light probe to build the skybox as well. Yeah, so the message here is that you can get something fairly nice like this fairly easily. Yeah, so let's move over to mixing 2D and 3D. That means we have two modes for this. There's a textured path and a direct path or inline path for both 2D and 3D. Scenes can still be rendered into textures. That's still a flexible way to do it if you need to apply, say, that scene on a model that's not flat, say a cylinder or something like that. But both 2D and 3D items are defined in the same scene. So if we look at the example here, we have a button on line 27, which is just defined in line in our 3D scene. And that's pretty much all it is to it. This item, which is a quick control item, a button, will then be rendered inline by the 2D engine, so quick. So what will happen is that when we get to this item, it will branch off to the quick 3D engine, quick engine with the 3D transform, and that will position and draw the item as expected. The nice thing of this is, of course, that there's no need to go through offline rendering, and so we don't pay any extra cost for that, which we have discovered costs a lot of on some devices. The drawback of this is, of course, it's flat. As I said, the textured mode you can apply to a model. You cannot do that here unless it's flat. You can position it so it is on a flat surface, but it's still going to be a flat item. I also highlighted on line 31 that the coordinate systems in the 2D world and the 3D world are slightly different, with the Y position flipped. The consequence of that is that if you want to position an item, quick item in the 3D scene, you should be aware that you either need to do this or maybe better wrap the item in a node, and then you can position it more logically in the 3D scene. Another thing to be aware of is anchoring. Anchoring actually works, but when anchoring to a 3D item, it will use the center of that object as its reference point. So you might need to put some an offset to get what you want. Yeah, and then we have the texture path, which is a bit more involved. As you know, need to set a material on some model that you want to render that source scene to. So you can see here on line 33, we have a texture. It has a source item property, which you can give your quick item. And that will then be rendered into a texture and become the texture, and you then can apply that to a model. This is very flexible, but again, there's some caveats here, especially when it comes to zooming and getting close to items that are going through a texture. They will not appear that crisp. They will get blurry, same way as you would if you scale an image. You'll get some of that if the size of the item is not correct. And that's usually not that easy when you're constantly moving the camera or scaling items. So here I put both of the modes side by side. Of course, I've exaggerated the left side, which is the texture path, a little bit, but it shows the kind of effect you will get when you go through a texture. This texture, as you saw in the example, is on a rectangle here, and of course, when you get closer, the texture will get stretched to fit as the rectangle gets bigger. The opposite happens, or not the opposite, but as you can see for the inline rendered or direct rendered item, it stays really crisp. The same with the texture, but also the lines around the button. It looks really nice and crisp, and it will do that at whatever distance you are to it. It will render from Quick 3D with the correct information in 3D Transform. So new features in 6.2. Are instancing. Which I've shown here. That's tech preview in 6.1. We lifted the tech preview for 6.2, so it should be fully usable. And I don't think we did any big changes to it. Yeah, I came up with this horrific example. Again, this is the exact same example I started with. The only difference is I put the push button as a texture on the cube, and put instancing using random instancing, having random position and colors for it. I think there's about 1,000 cubes here. Yeah, so instancing is, of course, about drawing the same object multiple times and then doing it in one draw call, which makes it very efficient. The bad thing, of course, is that there's only one of these cubes that is the real one and that you can push. Next is particles. We added 3D particles, that is. That's the 3D version of the particles. You might be familiar from Qt Quick. This also was tech preview in 6.1, but that also has been lifted now for 6.2. It uses instancing for the model mode, which you see here. There's two modes for doing particles. There's the model version, and there's a sprite version. Both instancing and particles have excellent blog posts. I recommend looking at those. I'm not going to dig deeper into this today, so yeah, please have a look at those. Runtime asset loading, I already mentioned. So in the picture here, I've also enabled instancing for that. That's also supported. So I don't remember how many models were used here, but same thing. We're doing instancing with that whole model with random position and caller. The API, as I also touched on this, the API for this is not that extensive yet. It's completely new now for 6.2, and so we're investigating ways to give better access to the sub components at runtime, but that's something that will come in later versions. Last feature added for 6.2 is parallax occlusion mapping. That's a more advanced technique for doing bump mapping or normal mapping, for those that's familiar with that. Basically, that's trying to fake depth, the appearance of depth in a model using textures and without adding extra vertices to the model. And yeah, it's pretty nice. It gives a really nice realistic look. Yeah. So what's next? Tooling. That's going to be a big point for us. We're going to spend some time getting Design Studio up to speed with the new stuff in Qt Quick for 6.2, and hopefully close the gap with 3D Studio soon. So those using 3D Studio will get a nice transition over to Qt Quick 3D and Design Studio. We're also going to look at the asset pipeline and add better and more support for formats there. I'm not completely sure what we plan there, except that that's a topic we're going to do in parallel with the improving Design Studio. And of course, getting feedback. We want more feedback about what's working well and what's missing and what people would see. Yeah, I think that's it. Thanks for listening in. And maybe if there's some questions, we can take them now.
Yeah, thanks, Christian.
Yeah, and sorry about the slides. That I don't know what.
Yeah, no problem. There's one question from Hannah. She's asking, are there any plans for Qt Quick 3D and AR/VR applications, or Steam VR or OpenXR? Or
yes to all, I would say. We're experimenting with this. I don't think we have like a version set for that yet, but there's versions and prototypes floating around testing this. So definitely something that will be coming.
Okay, and Nuno asks, can you show, I don't know if it's already done, so maybe he asked, can you show an example of loading the GLTF at runtime and interacting with it? And do you import the camera lights and animations at runtime, and how do you expose them in QML?
Yeah, so I cannot show that here. The code is available already, and there's an example showing it off. That's the one I showed. Yeah, so it does load the whole scene. So it does load cameras, animations, and the whole lot from the scene. The problem is that, as I said, the API is fairly limited yet. I'm investigating ways to expose those things. Of course, you can have multiple cameras and animation tracks, and we need some way to expose that. But at the moment, we don't have that, and it would require using private APIs. But fully possible if you're willing to dive into those private APIs.
Okay, yeah, that's it for questions. So thanks again, Christian.
Yep, thanks.
Okay, next up in this room is DevTrack, the next generation. And in room 1, we have how we can solve the personal data problem. And now we have 5 minutes until the next talk starts. Okay, we're getting ready for the last talk in this session already. This talk will be by Igor. I won't try to pronounce your last name, sorry. And he will talk about snaps. So go ahead, Igor.
Thank you. It's okay. No one can pronounce my name. That's part of the game trick. So, hello everyone. I hope you're enjoying Akademy. And I'd like to entertain you for the coming 40 minutes. And hopefully you will also learn something new and useful for your professional work. I'd like to talk to you about snaps, a packaging mechanism, and a hot new thing in the Linux world. Well, reasonably. I hope you appreciate the first slide, though. Okay, a bit about myself. I'm a developer advocate at Canonical. I work on the Snap/Snapcraft advocacy team. My job is to bridge the relation between developers outside of Canonical and within Canonical to make sure that together we can have a better developer experience on all levels. Your ideas and ideas that we have in Canonical make sure that everyone gets the best experience. I'm a physicist by vocation, but Linux has been my passion and hobby for the last 15, 20 years, and I made it into a career at some point. I like to write books, and in free time, and especially when there's no Corona, I like to go to racetrack days around the world. So, next slide. Okay, today I want to talk to you about snaps and tell you a little bit more about what they are, what they do, what they're good for, and how you can apply them in your day-to-day development work. If you're packaging applications, if you're a user of different applications, where snaps can fit in that picture. I'll give you an overview of the architecture, of the syntax, and how you can publish snaps in the Snap Store. This will be a very quick overview, so some things or topics may look a bit weird or not deep enough. Don't worry, if you have any questions, you can reach out to me by email, which will be on the last slide of this presentation, and we can follow up with any questions you have. I can't see you and I can hear your feedback at the moment, but I hope you will appreciate the occasional light joke here and there on this and that slide. So let's start with the definition. What are snaps? Snaps are self-contained applications, archives, applications packaged with the idea to be secure and portable. If you're familiar with Linux and you've used Linux and deployed software on Linux, you then know that it's not always trivial. There's relatively low portability of applications between different distributions and even distribution releases. And to solve that problem, snaps come in with a mechanism of self-containment, meaning the application and the relevant dependencies are all bundled in one archive, and you can deploy them on any system that supports snaps, or the snapd service, if you will. And if it runs, then it should run reliably and consistently on all those different distributions. Today, the list runs more than 40 different distributions: the Ubuntu family, Debian, Fedora, RHEL, SLES, Manjaro, Arch, and so forth. And then beyond that, apart from the runtime, there's also the packaging of applications. Again, here, idea is to provide a useful, practical, and a relatively simple mechanism for people to publish their snaps. And finally, there's security, which is also important, goes side by side with functionality. And one of the advantages of snaps is that there are atomic, reliable transactional updates provided with the packaging mechanism side by side, so that end users will always have the latest and greatest available to them for use. We'll touch about this a little bit later on. Going back to the traditional Linux software delivery mechanisms, it's not always been an easy story. Going back the last 20-25 years, if you want to package and publish your application across multiple distributions, you do need some familiarity of Linux internals and how things work. The simple reality is that the application space and the system space are not easily decoupled. There's some level of intermixing, interdependency, and this has been known by different names: dependency hell, library hell, shared object hell, DLL hell, well, however you like it. The thing is, you package your application, and then if something changes one of the dependencies underneath, things can become complicated, applications may break, and you also don't necessarily have portability going from one distro to the other. The fragmentation and the non-transactional nature of this packaging can create problems for software developers and publishers. But then the fact that there is a problem with one doesn't mean that automatically a different solution is the right solution. So in this regard, I'm not here to tell you that snaps are the solution to all Linux application problems, and that this is the best, the ultimate packaging mechanism for all purposes. That would be incorrect and misleading. Snaps have quite a few merits and useful functions in a variety of domains, but there will also be use cases where snaps are not the best thing. So in the next few slides, I'd like to show you what they can offer you, and then from there you can deduce whether they fit your use case. And frankly, the answer might be that in some situations, snaps may not be the best solution for you guys. Okay, so the first thing is the discovery. There's the Snap Store, which hosts thousands of snaps, including some really big name publishers, popular open source software, some games, wine-based applications, which means Windows software, and a whole lot more. The Snap Store and snaps are available for any Ubuntu release from 14.04 onwards, and 40 plus other distributions. All software is welcome in the store, and it's a portal, or if you will, your one-stop shop to all things snaps. You can go there, search for snaps, browse categories, figure out if there's something you like, explore and discover new software, or just install something that you require. Then the installations are supposed to be simple, basically one click or one-liner, one command line, and that's it. And you should have consistent behavior across multiple distributions. That's one of the core premises. So if it runs well on Fedora, it should also run well on Ubuntu and vice versa. Because everything is bundled and packaged as a single archive, you should have fewer moving parts, which means fewer opportunities for errors, mistakes, and problems in the software lifecycle. There's another element here, which is quite useful for developers and publisher, and that's analytics. The Snap Store page for every snap that exists in the store has a metrics tab that allows publishers and their collaborators to see how their snaps are behaving and trending over the last X period, which could be as little as 1 month all the way up to 5 years. And then you can see how the snaps trend across multiple distributions, across multiple release channels, different versions of your application, and you can also correlate to, say, social media campaigns, specific activities related to your code, and so forth. This visibility is another layer of functionality that's not traditionally available in Linux, because when you distribute through the distro channels, each distribution does its own thing. So you may not necessarily know how the aggregate numbers are and how the applications is behaving, which can in some way maybe hamper your decisions on how to distribute software. Of course, if you don't care about this, it's perfectly fine. But if you do, then you do have this ability available to you. Lifecycle, it's another important thing. It's quite a bit of an overhead. Once you've released your application, your real job actually just begins. The initial release is only the starting point. And from that point on, you have to take care of bugs and issues and security vulnerabilities, new major releases, testing, and so forth. So on 2 levels, one, Snap allow publishers to release updates instantly to their users. A client system that runs Snapd will by default contact the store 4 times a day. And if there's an update available, it will pull that update, install it in a safe transactional manner, roll back if that update is unsuccessful, and provide security to the end user and also the reliability of delivery to the publisher. The updates are cryptographically signed to reduce the chance of tampering. Snaps should work even if your system stops receiving updates. So because snaps are decoupled from the underlying operating system, they have their own management mechanism, which means applications are fully up to date. Your system might not be, but you don't really care because the applications are the internet-facing side of things where you need to put most of the focus. Finally, you can also publish snaps in different channels, going from edge all the way to stable. There are 4 levels, and that allows you also to differentiate different versions or different revisions of your software, and allow for additional testing and provide additional flexibility and functionality to your users. Okay, so this is kind of like a little promotional piece. Now let's go a little bit into the mechanics of how things are. Snaps have, or the Snap ecosystem, if you will, has 4 major components. There's the store that we mentioned earlier. Then there's the Snapd service, which runs on a system and provides the interface to the store. There's the user space component of the service called Snap. And finally, for developers, there's the Snapcraft command line tool, which allows you to package and publish your snaps. And this is where things become quite interesting. Here's just a little graphics for you to enjoy and appreciate. This took a lot of effort creating these 4 boxes and lines. So yeah. So back to the serious bit, Snapcraft. So it's a command line tool, and it's actually quite a nifty and powerful utility. It's a command line tool, which means, all right, you do need to work, be familiar with the command line and be comfortable working in that manner. Once you run Snapcraft, putting aside for how the pieces in the middle work, your final artifact will be a snap, which is a squashfs file system compressed with the .snap suffix. Inside this archive, there will be all of the necessary application code and library dependencies that allow the snap to run independently, plus, of course, some declarative metadata. So that means that, let's say that you have a browser and you want to package that browser as a snap, then you will also put all the different audio libraries, video libraries, codecs, and all the other necessary interfaces and elements that your browser will need. So even if they don't exist on the host, they will exist inside the snap and provide a functionality, cryptographic libraries, and so forth. To get to that final artifact, the snap, you need to use Snapcraft. And how it works is it basically reads a recipe declared in a file called snapcraft.yaml in the YAML format. And if you have done any packaging of this nature before, for instance, say RPM spec files, it is kind of similar. The recipe that declares certain informative pieces, and then you have basically like declarative code functions, which are then executed when Snapcraft runs and builds the snap. What this actually looks like is, here's a rather trivial example of a command line utility. Weather, it's called weather. It's a weather tool, and it allows you to check current weather for different locations. That's what the binary does when you run it. To package that binary and create the application, the snap, you have these 15 odd lines of code in the YAML syntax. So basically, we have some metadata, then we have the application declaration and the bits and pieces components declaration, which is called parts. I will go into this in a bit more detail in just a few moments. In this particular case, this is a Node.js application, and it doesn't have that many components, and it's not really complicated. So of course, this doesn't necessarily reflect how difficult or complex things will be when you package snaps, but it actually shows you that this is not something completely outlandish and completely foreign. It's just a bit of set of declarative instructions, and you let the tool know what it needs to do to package the application. So in a bit more detail, the first part of that code that we mentioned earlier is metadata. You provide information by which your application can be searched and cataloged. We have things like name, version, summary, and description. And there are some limits on what you can do and what you can use. It is quite useful to take into account specifically that version is a string. It's not a number. So there is no semantic meaning to what you put into your version. Your version could be a number per se, but it could also be something like Igor 1, Igor 5, or whatever you like. Then there's a summary and then description. You can also use Markdown, which will be parsed once you upload your snap to the store and shown in the store description. So you can have additional visual elements to appeal to your users and provide differentiation to its functionality as part of that description. The next interesting thing that, if you remember what we've seen earlier in that snippet of code, is confinement. So a concept that may not look or sound quite familiar from the traditional Linux packaging world is snaps are designed to run isolated. And this isolation is on two levels. One, code isolation, so that functionality is available and consistent, but there's also the security element. Snaps are designed to be secure and completely separate from the underlying operating system. And a fully confined snap can't really do much. It can't talk to other snaps. It cannot change anything on the system underneath. And in that form, it's kind of useless. But to make snaps useful, there is also a concept of something called interfaces. You can basically punch little holes in the security confinement and allow granular control and granular access to specific system resources. For instance, your browser will need access to the network. It will need access to video and audio resources, maybe USB, but it doesn't necessarily need access to sys or proc, or you don't want to give it access to control the network, and so forth. Well, so we'll see that in a second. There are three confinement levels: strict, which is the default level, and the preferred level. And by default, you have very little access, which you can override with the interfaces. Dev mode is pretty much like strict. However, instead of hard errors, you get soft warnings. And it's useful for developers to figure out what kind of interface overrides they need to provide to make their snap functional once they publish it for real, so to speak. And finally, classic is it's a tricky mechanism. It's an interesting mechanism that provides system-level privileges to the snap. And it's used as an interim stopgap measure for any application that cannot be currently packaged as strict, but may be packaged like that in the future, or for applications that need arbitrary access to locations and binaries, like, say, IDEs. In that way, you can also have a snap that pretty much does anything like a classic, normal, standard Linux application. That's the last confinement. For the weather example, we had a strict confinement. The isolation pretty much works like this. Each snap has its own private space. The snaps are mounted as read-only file systems with a separate private writable area, so there's persistence across runs. Confinement is provided between snaps and the underlying system with multiple levels. There's C groups, there's seccomp, there are up-armor rules. You can read more about this if you're interested in the snapd documentation, or you can contact me and I can give you a much longer and interesting overview. Or, given that you have my name from this presentation, just go onto the Snapcraft blog and have a read in the last couple of months, a few interesting articles on these different topics. Another interesting and useful concept that you wouldn't have encountered in the classic Linux world is base. Base is the best way to describe it is snaps need a root file system to run, but they don't actually see the real root file system on your host. They're strictly confined and isolated. So to have something to act as a root file system, there's the concept of base. It's a special kind of snap which contains a minimal set of runtime libraries to allow the snaps to run on top of them. And usually bases are matched to an Ubuntu LTS release. So for instance, Core 18, a base, is an Ubuntu 18.04 LTS set of libraries that allows snaps then to run and think that they're running on top of Ubuntu 18.04. So even if you run on Fedora, say, or SLES, your snaps will still interface and interact with the core 18 or core 20 for that matter, and be able to use the libraries matching that base. However, there's nothing that stops anyone from developing their own base. You can have a Fedora base. There's a proof of concept available as a GitHub project, and we actually welcome and invite other people to, if they want to develop their own bases if they feel there's a need for that. Build definition is the last part of the YAML, and it contains two parts. There's the application definition, where we declare the application, and the interface overrides. That's done by the keyword plugs, which then says this application needs to plug in to the network interface and or other interfaces, and then it will have relevant access and functionality. And the parts is the component where we declare the sources from which the application will be assembled. These could be GitHub repos, this could be local files, zip files, the Debian packages, PPAs, and so forth. You have a really wide variety of available sources, and then available language plugins like Go, Node, Autoparts, and so forth, which help you and simplify the packaging process. So if you're not 100% sure how to do some things with plugins, you can actually abstractize lots of the common bits and pieces and just override the things that you need. So basically, here's a slide that pretty much repeats what I just said. You need to pay attention to how you declare your application and what name you give it. Usually those match, but if your snap contains more than one application, then you will have to give different names, of course. The command will be, the command keyword will point to the path for the executable inside the snap. Parts, again, in this specific case, like I said, sources needed to assemble the app. You can override specific source tags. Under version control, you can point to different URLs where the parts will be found. Those parts can also be local. They don't have to be online. And if you're building a closed source application, then logically, you will not provide the sources, and they will not be available for anyone than yourself. Snapcraft has lots of commands. It's a complicated and very useful tool. So when you want to build, you just run Snapcraft. But then if you have built and something doesn't look right, you can clean specific parts in the life cycle. You can initialize a work project. You can then push a snap to the store, register a snap name, and so forth. There's really a lot that I can't possibly cover in this presentation. So again, please feel free to contact me, and I will gladly guide you through some of the more complicated steps. The idea of Snapcraft is also to help you isolate your work from the underlying system. So when you run Snapcraft, it will not run on your host. It will spawn a virtualized or containerized build environment. It has two backends. It has multipass, which creates virtual machines, and it has LXD, which creates lightweight containers. So you can run Snapcraft with either of these two. And inside the container, which will match your build declaration, all the packages will be downloaded, assembled, and built. You will not be polluting or changing your underlying host this way. And that's quite useful, because if you pull some libraries that would conflict in real life with your underlying host system, that will not happen. You will not cobble or destroy anything. All of this happens in an ephemeral, destroyable build environment. Once you're done, you can delete the container and no harm done. Once the snap is created, and this can sometimes take a few takes because you may have errors, you may not have necessarily declared all the relevant information, you may miss a library or two needed for the application and so forth. But in the end, if you're successful, there will be a snap in the work directory. And the snap will have a name.snap, will have a name.snap suffix. Now, once you have the snap, you can actually inspect what's inside it. So what you can do is unsquash the file system. You can unsquash the snap and then look inside it. And you will see that it will have a structure that is very similar to a Linux system. There will be a whole bunch of different libraries, like directories, like bin, lib, user, userlib, and so forth. It will mimic, in a way, the normal Linux structure, except these libraries and the components inside these directories will run on top of the base that we mentioned earlier. This way you can also see how Snapcraft works and what it does in the end. It can look a bit complicated, but then once you go into the details, it's kind of self-explanatory in some way. To understand the file format and what's happening inside, you can think of if you've ever run your own application with your own library overrides with LD library path. And so the application components will all be relative to what's inside the snap. And there's a whole bunch of $snap environment variables that reflect these different locations. For instance, $snap is the read-only installation path. Then $snap data is the writable path that resides under var. But then you reflect it with the environment variable inside your snap, rather than an external path that you cannot access directly. Again, it's not trivial. We can talk about this separately if you're interested in more details. Publishing the snap, that's your next step. You need to register for a developer account in the Snap Store. Then you need to register your app name. Ideally, it will not conflict with an existing one or try to mimic too closely a popular, well-known application for whatever reason. And once you do that, you can push the snap to the store. And ideally, it will pass all the checks and be published and available to your end users. You can do this on the command line with Snapcraft login and then Snapcraft push. You should push to a non-stable channel by default, because you can't really be sure that everything is perfect, and you should allow for some testing, ideally a lot of testing, by your end users. You have, again, a lot of flexibility here, because Snap Store channels offer you a multi-dimensional flexibility. You can use tracks to trade off between stability and new features. You can have something like a track number 4 and then legacy or whatever. Risk channels that we mentioned earlier. You can have beta, you can have edge, candidate, stable, and you can even create optional branches for temporary releases and bug fixing for your team. So you could have something that goes into edge, but that will be called fix number 73. Examples for different tracks, which you can use, long-term support, major and minor releases, however you feel like about it. Risks, as mentioned before, this is the most important aspect in the sense of quality control. You have the stable channel. You can reference it in multiple ways, similarly, candidate, beta, and edge. Your end users have the option to switch between different channels. So if they install a snap, by default, it will be from the stable channel. But then you could go, oh, I want to refresh my snap from candidate or from edge and use and try a different version. Another advantage that snaps have is that you can have parallel installs of the same snap. So for instance, you can have Ocular, Ocular 1, Ocular 2, Ocular 3, Ocular 4. It will all be Ocular snap, but then each one can reference a different channel. You can have edge, you can have candidate, beta, stable. Compare different major versions, try different versions, see how things work out. So like I said, when you upload to the store, don't use stable right away. Start with something less stable. There will be an automatic check of your snap, and if it fails for security reasons, then there will be a manual review by the store team. Your snap, once it lands finally and is available to end users, should be appealing. So you should make sure that your users will want to install your snap. So you should provide screenshots, videos, descriptions, and so forth. You have quite a bit of flexibility here as well. The Snap Store is, well, it's in the name, it's a store. So you should make sure that when people search for applications and want to install something, yours will draw the eye and provide the maximum useful information to people considering your tools. This was quick, I know, and there are probably a lot of questions, so we have about 10 minutes. I'll try to answer as much as I can. I think the organizers will paste the questions in the notes in Big Blue Button where I am, and I'll answer as much as I can. Just to move on to the next slide, here's my email. So any questions you have on this topic, complaints, if you didn't like this, anything you would like to know, I'll be more than glad to help, point you to the right sources, get you in touch with the right people, even organize a workshop if you want. So go ahead, Igor.
Yeah, thanks, Igor.
Yes. Thank you.
Yeah, we have a few questions. So Nate is asking, what do you see as Snap's main advantage over Flatpak?
Okay. I love the question, but I'm
Yeah,
not.
I knew you would.
No, but I'm not going to answer it because it will not be fair of me. First, because I work for Canonical, I'm biased, right? So my answer is not valid. I'm not going to talk trash about the competition. I'll give you a more political answer. Choose the best software for your needs. Install Snap, install Flatpak, compare them, and see what they give you. Because the answer is always in the end use case, in the end functionality. Maybe for 100,000 people, one will provide the best results ever, but for yourself, that's not relevant because you don't care about that, you care about something else. So that's my political answer. I'm sorry.
Yeah, thanks a lot. Next question, Thiago asks, can I build snaps from any distro other than Ubuntu, or do I need to be on Ubuntu to build them?
You need to have Snapcraft installed on your system. That's actually a good question. I didn't think about it. It's a good question. I'm not sure. I haven't tried it. I think that if Snapcraft runs on your distro, then go for it. You will need the backend, you will need Multipass or LXD to create a virtualized environment. From that point on, once that's bootstrapped, should be fine. But it's actually a good point. I haven't tried it. I'll have to come back to Thiago with this reply. So, yes.
Okay, then next question. How can Snapcraft help simplify building with dependencies from NPM, pip, Ruby gems, and other dev package managers?
Okay, so Snapcraft actually has plugins for these languages. There is an NPM plugin, there's a Ruby plugin, and they can help you define, bootstrap, and grab the relevant resources, pull them into your Snap, and then assemble your application. Electron Builder also can build snaps as an artifact. Now, this is a very generic reply. The question is, what is the specific use case that you have in mind? And maybe then we can go into details and understand exactly what you need to do. But if you say have a Ruby-based application, or you have a Go-based or an NPM-based application, you can do it with Snapcraft. Use the plugins, get the necessary modules, get the necessary packages assembled and packaged. And you can also provide overrides to the build definition if there are specific instructions that are not available in what the plugins do. If you go to the Snap Store, you will see there's a lot of different applications created in different development languages, the development frameworks, and lots of them use these different plugins.
Okay, thank you, Igor. That's it for the questions.
Okay.
Already, yeah. So maybe there's some more discussion happening in the talk chat room. I don't know.
Okay.
Okay. So for now, thank you, Igor, again.
Okay, should I hang around for another 5 minutes or drop early?
I guess you can drop now.
Okay, well then I'll just a couple of closing words. Thank you for listening, if you were listening. Hope you found this useful, interesting, and maybe ever so slightly entertaining. Thank you for the organizers for the opportunity to speak, and see you around, folks. Thank you.
Bye. Okay, next up in room 1. So this ends the session in room 2. And we will continue in room 1 with talk about KDE network by Vishal Dhruva and other people. So see you there in room 1 in 5 minutes.